there with factoring. Okay, so like I said, guys, I really truly expect you to be like excellent factors after we spent a whole day on it. You will see this through the rest of the year, so we've got to get better and better at it, and it comes with practice. So if you need to go watch the factoring video, make sure you do. So I want you to look at your whiteboards and go through this with me, check your answers. If not, pay close attention, because really, guys, we will have to weed out some of you by like midterm. Some of you are going to be put in something else, and especially, I mean, if you can't factor, you can't make it. So just push yourselves. If you need to go home and watch a video, then do. Okay, so we factor it. So the first thing we say is, what are we doing? What kind of factoring? So we first see, this is a quadratic, correct? Degree 2, right? It's in standard form. So we always say, okay, my A value is 7, my B value is 41, right? My C value is -6. So this is how we factor quadratics. We say what multiplies to be A times C and adds up to be B. So A times C is -42, right? Well, multiplies to be -42 and adds up to be +41. So then you listed out your factors, 1 times 42, right? 6 times 7, right? Also, and that's about it. So then we'll say which ones could possibly add up to be +41. 1 and 42, right? Now it needs to be +41, so this one would have to be negative. Then check in both cases. Does -1 times +42 equal -42? Yes. Does -1 plus +42 equal +41? Yes. So our factors are truly -1 and +42. So then we have a process called drop and break. So we drop down our end terms exactly how they are. Drop, 7k squared. You drop down this, including the sign, drop. And then you break. You're breaking down the middle term. Now remember, you're rewriting 41k as those two factors, but they have k's on it. I saw some people forget to put a k on it. Order doesn't matter, so I'm randomly just going to go with -1k plus 42k's. Do we have questions up to here? Drop and break. Then we say we have 1, 2, 3, 4 terms, and anytime we have 4 terms, we factor by grouping. So we group those 2 terms, we group these 2 terms, including the sign. Now focus on this group. What's the greatest thing in common, guys? Tell me. Just a k. So we're pulling out a k. So then we go back through and see what's left in our parentheses, divide each term by k. So we'll have a 7k minus 1, correct? Now we're going to look at this group, factor out the greatest thing in common. We always factor out that sign with it. So it's +6. You guys, I see a lot of people not writing this. +6 is what we're factoring out. They forget the plus. So then divide each term by 6. So then we get 7k's minus 1, right? 6 over 6 is 1. Then you check your safe haven. You can say, I know I factored this correctly because inside my parentheses is exactly the same. So now we factor that out. We factor out 7k minus 1. So then what's left in our parentheses? Well, we factored that out, so it divides out. So then k plus 6 is left in our parentheses, right? Okay, good review. I really, really, truly expect you to just be excellent factorers. Okay, any questions? Okay, sweet. Let's go to today's lesson. Okay, so first of all, we're going to be graphing quadratics and graphing absolute value functions today. Graphing them is actually quite easy. Make sure you have your graphing calculators out ready to use. So make sure you have that out, ready to use. So first of all, we're going to graph a quadratic. I just want to remind you, standard form of a quadratic looks like this. ax squared plus bx plus c. This is the form we look at for quadratics when dealing with factoring or solving a quadratic for the most part. And then vertex form of a quadratic, that's actually what we're going to be using today to graph. So we're going to graph vertex form of a quadratic because that's the easiest way to graph a quadratic. And vertex form of a quadratic looks like this. A times x minus h squared plus k. So they're the same thing, just different forms. And you can write from vertex form to standard form and standard form to vertex form. That's a whole nother lesson though. So today we're just going to give it to you already in vertex form. It's the easiest way to graph, and then we're going to graph it. Which graphing them is actually quite simple if they're in vertex form. All right. So this is the important part to write down right here. So vertex form of a quadratic, like I just said, looks like this. A times x minus h squared plus k. So if it's in vertex form, a quadratic, it's easy to graph it. And how we graph it is, first of all, we have to be able to identify the shifting and how shifting works of a quadratic. And that's what we're going to focus on first before we graph it, is how shifting works. So write this down. So first thing is, if you look inside, I'm going to start right here. If you look inside your parentheses here, this is your shift. This is what shifts the parabola left and right. Everybody, inside the parentheses is what shifts the parabola left and right. And you always go opposite of the sign. So if this was x minus 3, we would go right 3. Do you understand what I mean by opposite of the sign? If this said x plus 2, we'd go left 2. Does that make sense? So you look inside your parentheses, that's your shift left and right. So it takes the quadratic and shifts it left and right. Questions on that? We always go opposite. That's the important thing. Yep, this inside here is what shifts our parabola left and right. So it takes our quadratic and shifts it left and right. You always go opposite of that sign. So if that was x plus 3, that's the shift left. It'd be opposite of plus. Does that make sense? Opposite of positive. If it was x minus 3, we'd go right 3. And then this out here, if there's something added to your function on the outside, added to it, that's what shifts your quadratic up and down. And you do go with the sign. So this sign stays the same. So if it said plus 3, we shift it up 3. Does everybody understand? This is what shifts the quadratic up and down, and the sign stays the same. Now this is where this next part you got to look at. This a value that's multiplied to x minus h, that's the acceleration of the quadratic. And if your a value is greater than 1, it's called a stretch. Now think about why that is. I don't want you to have to memorize it, because if you think about why, it's going to make more sense. So if I have a normal sitting quadratic, it looks like this, right? I'm actually going to draw this. If you have a normal sitting quadratic, it's going to look like for example, look like this. If this makes sense to you, you're not going to have to memorize anything, which will be really nice. Okay, so if I have a normal sitting quadratic, let's say it looks like this. Now, if the acceleration is greater than 1, it's going to be larger, right? It's like getting larger quicker. So won't that make it more like this? Do you see how the acceleration is larger quicker? Squishing it in, right? So that's called a stretch, okay? Because we're stretching it in. Now we're taking and we're stretching it. We stretch it this way. That's what usually confuses people. So we're taking, do you see how we're taking the quadratic and making the acceleration greater? So that's stretching it up like this. You see how it looks stretched out, like a rubber band. We're all good. That's why that's called a stretch. If your a value is greater than 1, the acceleration is greater, so it stretches up. Now, if your a value is less than 1, if your acceleration is smaller than 1, there's less of an acceleration, so it's more open like this. That's called a compression, because I'm taking it and I'm squishing it, compressing it, so that there's less of an acceleration. So if your a value is less than 1, it's called a compression. You're compressing it down. If that makes sense, it's a lot easier to remember, okay? And you'll refer back to your this often. Okay, and then last but not least, I have to say this one thing. We only compare the positive a values. So if there's a negative, you can't say, oh, that's less than 1. The negative doesn't matter for less than 1. The negative simply is its own transformation, and that's called a reflection over the x-axis. So everybody look up here. If I have negative 2, you can't say, oh, that's less than 1. You look at the absolute value of negative 2. So it's 2 is greater than 1, right? So this is still a stretch. The negative, however, flips it, reflects it over the x-axis. So these are the transformations, and that's how we're going to describe it to begin with. Does everybody have those written down, and then we'll practice, and you'll understand it better. Okay, here we go. Are we good for me to go to the next page? You need to take a picture of that. Okay, so let's determine the shifts on all of these. This is going to be on your test. I saw the test yesterday, and I helped write it. Here we go. So determine the shifts of the following functions. So the first thing I look at is what's my shift left and right. We're going right 2, right? We always go opposite. Questions on why it's right 2. Okay, now we look out here. This is a shift up and down. Sign stays the same, so we're going down 1. Is everybody comfortable? Now you look at your A value, and isn't 3 greater than 1? So our acceleration is getting larger, so that's a stretch. So you would say stretch of 3. That is all of the transformation written in words. Are we all comfortable? Next example. So we look right here. This would be going left 3. We always go opposite of what's in the parentheses. Yes? Because here's why. Because technically, like if we plug in, now here's why. If we plug in, so this is the actual, sorry, let me go back. Here's why. This is what a shifted parabola looks like, right? So if I plug in -3 right here, won't it be minus a -3, which makes it positive? That's why we shift left 3, because we were actually plugging in negative to get positive. Does that help? If you were going to plug in a negative, if I said left 3, yes, you would plug in positive. Yes, good question. All right, so continuing, this one's going left 3, up 4, correct? Yeah. And then looking, oh, there's a negative in front, that's a reflection over the x-axis. You would say reflection over x-axis. So that's flipped upside down over the x-axis. Okay, next one. This one would be, you tell me. Right 2, up 1, and stretch or compression? It's a stretch, right? We don't look at the negative. 2 is greater than 1, so it's a stretch of 2. And then because of the negative, another transformation happened, a reflection over x. Good. Okay, we're all good with those. Okay, last example here. This one, 1/2 times x plus 1 squared. What's my shift left and right? Left 1. Any shifts up and down? No shifts up and down, so we just don't need to put anything. And then looking in front, 1/2. 1/2 is less than 1, right? So isn't our acceleration less? Yeah. Compression of 1/2. Very good. Questions? Are you ready to practice? We're not solving, we're describing the shifts. Right? Okay. Let's just get to graphing because it's actually really easy. Then I'll just let you practice for quite a while. So actually stay with me for another couple seconds. We'll be able to finish this out decently quick. So quadratic's parent function is the non-shifted function. So if I say to you, here's the parent function, it just means the basic, most non-shifted function. So does everybody see how y equals x squared has no shift left and right, no shift up and down, not reflected, and it's not stretched or compressed? Does everybody see how x squared is the most basic non-shifted function? That's called a parent function. So don't get confused when on the test I say, describe the transformation from the parent function. That just means where did we shift from the original function? Does that make sense, everybody? All right, let's get to it here. So take a picture of it or something. These are how we're going to graph. Now that you understand shifts, graphing a quadratic is pretty easy if it's in vertex form. All right, so the first step we do when graphing a quadratic is we first determine the shift of the function, and now we're good at that. That's going to be where our vertex is, the lowest or highest point of our graph. So we have a quadratic, the vertex is either the lowest point or the highest point of our graph. You graph that first based on the shifting. Then second, you can either just type it into your calculator and plot some points, which is great, which is what we're all going to do, because that's the easiest way. But I'm also going to use a trick, because a little trick I use to graphing, because I like to be able to graph quicker than using my calculator. So it's this rule that happens with quadratic. I call it the 1, 3, 5, 7 rule, and I'll explain in a second. So you'll use your A value for the second step. You'll multiply it to 1, 3, 5, 7, and that's how you'll graph the quadratic. That's where the points will end up. However, if that's too hard for you, You could graph it in your graphing calculator. I'll show you how to do that, and then plot points. Does that make sense? You'll use your calculator to graph it. And then even if we use this 1, 3, 5, 7 rule, which I'm going to use it, I want you to check your points using the graphing calculator, and I'll teach you how to do that in just a second. So here's our first example. Just look, okay? Just watch. So it says graph the quadratic. So the first thing we do, our first step was to determine the shift, plot our vertex. So don't we have a shift of left 1? Any questions of what? Left 1, and aren't we going up 3? Left 1, up 3. That's our first step. So we're going to start at the origin. We're going to go left 3 and up 1. There's the lowest. Left 1, up 3. Good. Left 1. So we're going, from the origin. Left 1 and up 1, 2, 3. There's our lowest or highest point. Now looking at this, there was no acceleration, right? There was no compression. It's just a 1 in front, so we're good. It's not an acceleration or compression, and it's not reflected over the x-axis. So we know this is an upward-facing parabola. Awesome. So now we need some more points up here somewhere. So let's first just do it using our graphing calculator. So everybody pull up your graphing calculator. Remember that the function is x plus 1 squared plus 3. So everybody pull it up. Go to y equals, and type in parentheses. X is right here, right? X plus 1, close your parentheses, squared, plus 3. Now hit graph. Do you see the parabola? Okay, so now instead of looking at this graph, let's look at the table of values. So how you do that, instead of hitting graph, you'll hit the second key, and then graph. And that'll give you a table of values. So does everybody have those? What do you mean no? Then you type something, then your window's bad. Everybody go to window. A standard viewing window is for X min, that means how low you want to see on the X-axis. Look up here so you understand windows. In secondary mastery, you have to understand how your windows work. So X min means I can see as far down as -5. If I want to see further down, I could change that. Mine's right now at -5. If I want to see down to -10, I could, but I don't care to see further left or right. X max, it says I'm only seeing up to 5 on the X-axis. Now look, I wouldn't mind. X scale means we're working in ones. I never change X scale. Y min means as far down on the Y-axis as I want to see is -5. Do you see how this is down 5? But look, it wouldn't hurt to see higher up on Y. So I'm going to go down to Y max, because right now I can only see up to 5. And I'm going to hit 10, positive 10, because Y max is the Y values up here are positive, so that has to be positive. And now I'm going to hit graph. And now do you see how I can see a little bit better? Okay, anyways. So now hit second graph. We want the table of values. These are the table of values. So these are x, y points on the parabola. So everybody tell me, what are some whole number points? Look at your calculator. Like, is there any whole number points? Like between -3, -4, and -2. Is there any whole number points? Look at your graph. Go scroll up to -2, -3. -2, 4. That's a point. Does everybody see where you can see it on your table of values? So if I go to -2, we're going to be up 1, 2, 3, 4. 0, 4. Awesome. So over 0, up 1, 2, 3, 4. 1 and 7. Okay. Over 1, up 1, 2, 3, 4, 5, 6, 7. -3, up 7. Is everybody comfortable with how I could graph this using my table of values? What don't you understand? You're just looking at points that are graphable, like not just like ones that are not decimal. Did somebody say no? Are we all good with how to graph it? Yes? Okay. Now here's the 1, 3, 5, 7 rule, which I'm going to graph with from now on. Okay. So my A value is 1, right, guys? My A value is 1. So 1 times 3 times 4 times 5, I'm only going to use those. What's 1 times 1? What's 1 times 3? 3. What's 1 times 5? 5. So I'm going to multiply 8 of those values. Then you always go over 1, up those values. Over 1, up that value. Over 1, up that value. So look, from here, I'm going over 1, up 1. Then I'm going over 1, up 1, 2, 3. Do you see that? Over 1, and I go up 5. Ding, ding, ding. Okay, we're all good. Okay, oh, I'm like sweating because I'm feeling like nervous that you guys aren't getting this. Are we all good? Okay, domain and range. Guys, domain is x values. Look with your eyeballs. From left to right, where's my function growing? Domain is left and right. So look, isn't this way, isn't my function growing this way forever? And isn't my function growing this way forever? Good, so domain is from negative infinity to positive infinity. Or I would also accept all real numbers. Now it doesn't matter how high up and down it is for domain. It only matters from left to right. So now range, change your eyes. It doesn't matter that it's growing this way and this way. Range is y values. The lowest y value on the graph to the highest. Where's my lowest y value? 3, and it's going to positive infinity on the y, right? So range is 3. It includes 3, so we put a bracket to positive infinity. This should not be new, guys. This should be like, I'm just reviewing this. Okay, we're all good. Okay, next problem. Let's go much quicker through this one. Ready? Let's go 10 times quicker. Right 2, yeah? Right 2 up 7. Let's graph that. So I'm going right 2 up 7. Okay, awesome. Now we're going to graph it. You can either use your calculator or the 1, 3, 5, 7 rule. 1, 3, 5, and 7. And we multiply our a value to that. So times negative 2 times negative 2 times negative 2. So we're going to be going negative 2, right? Negative 2, negative 6, right? So we go over 1, down 2. Over 1, down 2. You have to do it on both sides. Over 1, down 6. Over 1, down 1, 2, 3, 4, 5, 6. That was right here, right? And good enough. You see how easy the 1, 3, 5, 7 rule makes it on me? Okay. Now you could check that using your calculator, looking at your table of values. Domain, it does not matter, guys. For domain, it doesn't matter that it's growing downwards. That has nothing to do with domain. Domain is from left to right, whatever, and backwards with you guys. Look. So where's my function going this way? Positive infinity, where's it growing this way? Negative infinity, right? Yes. Good point. Yes, good point. So won't quadratic's domain always be positive infinity to negative infinity? Good. Good inference there. My range, lowest y value to highest y value. Isn't my lowest y value negative infinity, guys? Isn't it going to negative infinity? And it stops at 7. So our range is negative infinity up to 7. It includes 7. Infinity is not a number, so that's why we put parentheses around infinity. Awesome. We're all good? Are you ready to practice? Okay, go. I'm not going to do more. Ready? I want you to do those problems. Go, go, go. Yeah. Okay, so now we're going to graph absolute value functions. There's a difference between an absolute value function and a quadratic. You've got to know the difference. Absolute value functions are sharp V's. You've just got to know that from here on out. Absolute value functions, if I say you graph an absolute value function, you say, oh yeah, that's a sharp V. So V's versus parabolas. So if you draw your parabola as a sharp V, I'll mark it wrong on the test because they're way different. Now, does everybody see the difference? Yes? Okay. So the parent function of an absolute value function is y equals the absolute value of x. Remember, parent function simply means the non-shifted function. So looking at this, do you see how we're just starting at the origin? And then the one thing is for absolute value function is it's a slope, not an acceleration. Our a value is. So up 1 over 1, up 1 over 1, and I didn't draw this very good. So the parent function, I drew this terribly, in fact. Anyways, the parent function is a non-shifted function. So we're going to have these that are like this, and they'll be also flipped upside down. Shifting works the same for all functions, you guys. So now that you know how to shift a quadratic, you know how to shift all functions. So let's talk about absolute values. You don't even need to write this down. Just make notes. Still our shift left and right, just like a quadratic. Still our shift up and down, just like a quadratic. We still go opposite of left and right. We still stay the same width up and down. Does everybody understand what I'm saying? Shifting works the same. The only difference is this a value is not an acceleration, it's a slope. We always graph slope as rise over run. Slopes are graphed as rise over run. So you'll look at this A value and you'll graph it as a slope. So that's how we graph an absolute value function. Find the shift, plot the vertex, and then graph the A value as a slope. Rise over run. So these are the easiest ones. Here we go. Graph the absolute value function. So let's talk about the shifting. Want to be right one. Guys, right one, right? Right 1 up 5. So watch. I go right 1 up 1, 2, 3, 4, 5. Now you have to describe the shift like you would a quadratic. So this is a slope. You would say a slope of 2 because it's an absolute value function. You would say stretch, or well, you could say actually stretch or compression, but I'll also accept slope of 2. So we could also say, isn't this a stretch of 2? Right? And then it's a reflection over x. Okay, so just making sure we can also describe it. Reflection over x because of the negative. Now let's graph it. So we go right 1 up 5, boom, our slope is -2, right? Guys? So how we graph slopes, -2 is the same thing as -2 over 1. Rise over run. So we go down 1, 2 over 1. Down 1, 2 over 1. Down 1, 2 over 1. Now do it on the other side. Down 1, 2 over 1. Down 1, 2 over 1. Down 1, 2 over 1. And we draw in our sharp V. Now one more thing on a test, I might say graph or plot the axis of symmetry, which just means what's the line that this is symmetric on? Isn't that the line it's symmetric on? Right? So that is the line y equals 1. Do you see how our y value equals 1 no matter, oh, sorry. Yeah. I meant to say x equals 1. Isn't our y changing on that line? Look, isn't this like y of 6, y of 5, y of 4, y of 3? But isn't our x value always 1? Isn't that the x value always 1? So we would say our axis of symmetry is at x equals 1. So back here, if I said to you on the test for a quadratic, plot the axis of symmetry. Wasn't it right here? Where the parabola was symmetric over. Yeah. So we'd say, okay, our y's are changing, but our x is always 2. So x equals 2 is the axis of symmetry. All right, sorry, lots to review today. So are we all good with graphing an absolute value function, or do you want another one? Maybe we should do domain and range. Isn't it growing from -infinity to +infinity? It doesn't matter that it's growing down for domain. Okay? -infinity to +infinity or all real numbers is also acceptable. Our range is lowest y value, which is -infinity up to ding, 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 5. With a bracket because it included 5, it included 0.5. Okay, do you need another example? Are we okay? Okay, last one. Left 3, down 1. Left 3, down 1. Our slope is 1, right? So we go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Stay in the lines. Okay, so our domain is all real numbers, right? And our range is, lowest y value is at? -1 growing to +infinity. Are we all comfortable? Terrible handwriting. Yep, 1 over 1. So what if that would have been a negative in front? Isn't that -1 over 1? Down 1 over 1. Down 1 over 1. Good questions. I'm so glad you're asking them. Go. Finish the worksheet so we can get to literal equations. Ready, set, go. Finish that one so we can get to the good stuff. 1.4, finish it, and then we'll do literal equations. To get started, I have to go slower through this. So everybody, if you're working, please just stop, take that home, finish it, pay attention, because this is where it's a little bit more difficult. Other secondary 3 teachers omitted this. I'm not omitting it, because you will see it on your ACT, and it's really not that bad. We're advanced thinkers in here. This is pre-calculus level. Welcome to pre-calc. Yes. Yep, kind of new. Actually, it's in the secondary 2 core, but if your teacher didn't teach it to you, then it's new. So, what literal equations is just taking and solving for any equation in a expression. So it's actually really quite simple. You just got to be pretty good at algebra and not do any weird things. So everybody look right here. This is called a literal equation. You see how there's a bunch of variables? We can't actually solve anything, but solving for z. Can we get z alone? How would we get z alone first step? Subtract A, no, this is 2 times Z, right? So we got to use the correct algebra. When we subtract A from both sides, since A is being added. Subtract A. Now you can't combine 8W and A, so we will leave it. 2Z is equal to 8 plus W minus A. Sweet. Now to get Z alone, last step is divide by 2, divide all by 2, isn't Z alone. We have solved the literal equation. That's it. However, this is where we see people do some really terrible, horrible things. Isn't 8 and W and A all divided by 2? Yes, right? So if you went and divided 8 divided by 2 and put a 4 there, you'd be wrong. Because then you pretended like W and negative A were not divided by 2, and weren't they? Yes. So this is as far as we can go. Okay, next one. A little bit harder. It says solve for Z. We're trying to solve for Z. Look, Z, I'm going to highlight it. We're trying to solve for Z. We've got to do this in the correct order. So first of all, isn't this all divided by X? What undoes division? Multiplication. So we're going to multiply both sides by X. Doesn't X over X divide out? So we have ABZs plus 2Ws is equal to 3X squared, right? Guys, any questions? Solving for Z correctly piece by piece. My first step will be to do what? Subtract 2W. Subtract 2W. Is everybody comfortable? So we have ABZs is equal to 3X squared minus 2Ws. Next step to get Z alone. Good. Divide by ABs, right? Multiplication. What undoes multiplication division? Divide by ABs. Isn't Z alone? We've accomplished our goal. That's solving the literal equation. Okay, awesome. Yeah, we're totally getting it. All right, looking at this one, solve for H. Looks harder than it is. Looks harder than it is, guys. Way easier than it looks. First of all, H, let's get this alone. H alone. Isn't H multiplied to R squared and multiplied to pi over 3? Now, really the correct way of doing this is to take care of the fractions first. So, do you see how 3 is being divided? I'm actually, because you would see it written like the way I'm going to do it on the ACT. Because there's division here, I'm going to multiply both sides by 3 first. So we have 3b is equal to pi r squared h. Does everybody see how I took care of the fraction first? That's what you would want to do. Now it's still multiplication to h, right? So we would divide both sides by pi r squared. Divide by pi r squared. Now isn't h alone? So h is equal to 3b's over pi r squared. So easy. Yeah. Yes, or watch the video. More examples are going to help. Sorry, I don't mean to rush. Normally I wouldn't. It looks way harder than it is, you guys. I promise you can do it. Solve for T1. So we've got to do this correctly. Here's T1. It's trapped inside the parentheses, right? Is it? Yeah, that's not a bad idea. That's not a bad idea, actually. We could times by L, but my first thing I'm going to do is take care of K times all that stuff. What undoes multiplication? Division. So I'm going to divide both sides by KA. That's what I'm actually going to do first, but you can do this different ways. So we have D over KA's is equal to T2 minus T1 all over L, right? KA is over here. The K's A is divided out, right? Now what? Now multiply both sides by L. Yes. Because we didn't need them anymore. Okay. Multiply by L to both sides. When you multiply fractions, you multiply straight across. That's L over 1, right? So DL is on top. All over KA times 1, which is just KA. Are we all comfortable? That's equal to, our L is divided out. T2 minus T1. We're solving for T1. Careful. Isn't this positive T2? So we would minus T2 from both sides, right? And I'm going to put it over here. Minus T2. So we have DL over KA minus T2 is equal to negative T1, right? Divide by negative 1, right? The entire side, all of it by negative 1. So I'm going to write this, I'm going to go up here. This is really just negative in front, right? Negative DL over KA, and a negative divided by a negative is a, so plus T2 is equal to T1. And we solved for T1. That one was a little bit harder. They come with practice. Okay, let's do number 17 on your worksheet. Here we go. Solve for A. So first step is to Number 17. Minus b from both sides. So we have g minus b is equal to negative CA's. Solving for a, what will we do? We're trying to get a alone. Divide by negative c. Okay, is it a alone? Now this is where we just got to simplify one last step. They don't consider it simplified on an ACT if you have a negative in the bottom. So really what we're doing is just pulling that negative out in front here. We're multiplying by negative 1. So won't that be negative g's, right? And then isn't a negative divided by a negative a positive? So plus b all over positive c now. You see how I just took the negative out and multiplied it through? Okay. And that's equal to a, and we're done. We solve for a. Okay, let's do another one off the worksheet. Now, negative g plus b over c equals a. So we can get to some of these more difficult ones in a second, but let's do 23 is a little bit harder. Here's why. It's different. Watch. Okay? Number 23, we have u plus ka is equal to ba. It says solve for a. So I want you to look at the problem. Isn't there two a's? If that ever happens, listen very carefully. If there's two variables and you're supposed to be solving for one of them, you're going to put all of those variables on one side of the equation and everything else on the other side. So do you see how this has an a and this has an a? We need those on the same side of the equation and everything else on the other side. So let's subtract ka from both sides. So we have u is equal to ba minus ka. So once again, if you have two variables and if you have two of the variable you're trying to solve for, the rule is get all of those to one side of the equation and anything else to the other. So there's nothing on this side we need to bring over, right? If there was like a 7 here, we need to bring that over. Does everybody understand? Now think about it, guys. On this side, isn't there an a in common in each term? So can't we factor out an a? If there's something in common, can't we factor it out? Yeah, right? That's what we were doing with greatest common factor. If I said, what's the greatest common factor? You would say a, right? Yeah. So we have u is equal to, do you get what I'm saying? What's the greatest thing in common on this side? A. We factor out an a. So then we go back through, divide each term by a, right? So then b is left minus k. Now looking at that, do you see how we have only one last step to get? Do you see how we only have one a now? Yay! How do we get a alone? Good. I like that you say divide. Isn't a multiplied to that stuff? What undoes multiplication division? We'll divide by b minus k. Divide by b minus k. So now look, b minus k over b minus k divides out, and a is alone. So we say a is equal to u over b minus k. Questions? Okay, let's do number 30. Let's do number 30, and the rest of the time will be yours to practice. You'll have 15 minutes to practice those. Here we go. Number 30, it says solve for a. On number 30. So we have two a's, right? Now, this one's a little bit trickier because we need to get all the a's to one side of the equation and everything else to the other. But careful, because isn't that negative 3 divided by ka right now? So we can't just bring the 3 over. It's negative 3 over ka. So let's get rid of fractions first. Let's times by something even more. Let's time both sides by ka so that we're not dealing with fractions at all. So I have ka to both sides. So I have kau, those are all multiplied, is equal to negative 2a minus 3 because over here, don't those ka's divide out. So now the rule is, you say to yourself, do I have two of the same variable? A and A. The rule is, if you ever are solving for a variable and there's two of them, get them to the same side of the equation and everything else to the other side. So let's bring this over. Let's bring this over. Add 2a to both sides. So we have plus 2a. KAUs plus 2a's is equal to negative 3. Right? Now look at this side. Isn't there a GCF in common? Greatest common factor. A, right? So we factor out an A, divide each term by A, divide by A. So then left is KU's plus 2, right? Because the a's divide out, right? Plus 2 is equal to negative 3. Now look, isn't there only one a, so we're golden? Last step, good. Yep, last step is a times all that stuff. What does multiplication, division. So we'll divide both sides by ku plus 2. Divide by ku plus 2. And we've just solved the literal equation. There's a really good chance you would see one like this on the ACT. I'm not for a while. But I'm going to prepare you all year. My students always have really high test scores if they're prepared. Questions? You're sure you're ready to practice? Sweet. Do the worksheet. Go, go, go. You have 14 minutes.